Hi, Mr. PK's fourth period class. Sorry no one is in there with you kind of teaching it, and hopefully you're finding these videos useful. This is going to be posted. This is a review for you to be working on or going through and making sure that you're ready for your quiz next week on earthquakes, the plate tectonics, and just the layers of the earth. So I'm going to quickly go through, kind of highlight the high parts since I made the quiz, so that you're all ready for that quiz on Wednesday of next week. Okay, so here we go. So this is one of our other teachers, Miss Parsons, made this up for us, and I think it's pretty good. So we're going to go through it. So the first one is the layers of the earth. And I said that the top and the bottom, or the middle layer there, are like bread, and they're solid. And the other stuff in the middle is liquid. So the crust is solid. And the crust is made up of different plates, which we talked about. Some of them are continental, which is the land, and some of them are oceanic, which is the water. And underneath the water, there's land. You know, you just don't sink down to the middle of the earth when you're in the ocean. So that is a solid layer. Right below there is the mantle, and we actually have two different layers of our mantle. We have the outer and the inner. The outer is more of a plasticky kind of sort of solid, but mostly liquid. It's sort of a slow moving liquid, and that is a liquid. The outer core is made of iron and nickel, extremely hot, but it is a hot liquid. And that's what makes our magnetic lines. So if you've ever seen geese fly from one place to another, flying south, how they know where south is because they're able to follow that magnetic line that goes through the middle of the earth. And if you've ever used a compass, you know, you use the magnetic line to find north, and then you can find your way around. And then the inner core is still made out of the same materials as the outer core, but because of all the pressure and gravity pushing on the whole structure, it makes it a solid. So if you think of a piece of bread, like a peanut butter and jelly sandwich, bread, peanut butter, jelly, bread. Okay, and that's the layers of the earth. So our earth is on a bunch of different plates, and about 240, 250 million years ago, we said that our earth looked like this, which is called Pangaea. Pangaea was first named by this guy, Alfred Wegener. I'm trying to see his name behind me too. He was a German scientist, and he said that South America and Africa fit together like a puzzle piece. And since they look like they did, they did. He also found fossils that were going across continents and across different rock layers that you were able to see across different places. And he said, with all that evidence, that we had one time in our existence on Earth, not us, but Earth and existence was created in this one big, huge mass. Okay. So, and we're on these plates that must be moving around, which then leads us to there are 7 major plates and up to 18 total plates on our Earth. So we have some smaller plates, especially in the Caribbean and off the coast of South America. And wherever these smaller plates are can often cause a lot of earthquakes. But these 7 plates are moving around, and some of them are older, like the continental plates, and some of them are a little bit lighter, like the Pacific plate, because of the oceanic. Now, as they're moving around, some of them are moving around. Why do they move around? Let's do that. So the next one is about why they move around. So why do these plates move around is because inside our Earth, inside that mantle, we have convection currents. So material would go closer to the outer core, warm way up, and then be sent up to the top. And then they would cool down as they got to the top and then go back down. And as that happens, if there was a break in the crust, or if there was a pressure of one thing hitting another, then it could cause those plates to move around. And that's why convection currents are there. Okay. Now we have 3 different types of plates. One is a divergent plate, and divergent plates is they're spreading apart. Okay. That has caused seafloor spreading. It also caused rift valleys off the coast of Africa, or on the east coast of Africa. And in the middle of our ocean, the Atlantic Ocean, we have that ridge running down the rest. The newest rocks are right in the middle, and then they get older and older and older as they go out. The second type of plates or plate interaction is convergent, and that is like when two cars crash into each other. And it's say this one is a 18-wheeler, and say this one is a little car. That little car is not going to do well, and it's going to get pushed underneath. It's going to subduct. And when it subducts, some of that magma from inside is going to come up and make volcanoes. It can make like a fold inside the earth and a big, large trench, big, deep valley inside the ocean. And then if we have two of them, two oceanic crusts banging in together, we get an island, and we can go visit them on vacation and see lots of beaches. So two oceanic crusts coming together, converging together. They're sort of the same density, the same thing, and as a result, we get little tiny pops of magma coming up, and then we get islands. And then the third one is where we have a collision zone. Two cars, same speed, same density, and they crash into each other. And what happens? Oh, we get mountains. And those mountains, depending on the collision, can continue to grow. The Himalaya mountains are an example of that, because the India plate is crashing into the Asian plate, and these mountains are growing, and Mount Everest does get bigger every year. And then we have our transform plate. The San Andreas Fault is a transform plate where they're going to slide past each other. And as they slide, they're sort of stuck, and then they slip. And when they slip, they cause big earthquakes to happen. It doesn't really change the landscape too much, other than if you're living in there, it may destroy your house or your business, but it will kind of move things along, okay? So what's on this one? So this is just some more text about what I just talked about, and another picture of those three different types of plate boundaries that we talked about. Okay. And then, so the biggest one is the transform plate. So that transform plate is where we're going to most likely hear of earthquakes in the United States. So as it goes all down the coast of California, and they think someday that this whole section of California may become its own little island right off the side here. So sometimes those earthquakes can go up on the Richter scale, like 10, 12, all those different things. They can up to 10, sorry, but they can be 7 and 8. And each time it magnifies by 10. So 10 times is great. So if you feel a 1 around here, sort of like a big truck going by, you kind of feel a little shake, that might be a 1, but a 2 is 10 times greater. And a 3 is 10 times greater than the 2. So that's how they go up. And this is an example. And this picture right down here, it's very hard for me to see that, is a Richter, what they would actually determine the Richter scale from. So the seismic waves that come out of an earthquake are caused by this thing down here. Let me see if I can get a better view of that. Nope, no better, because I'm in the way. But you can, when you look at it on your own, you can kind of see that these go up and down and up and down. And those are in the government buildings, and those are called seismographs. And we can detect how big an earthquake actually is. All right. Hope that reviews everything. You're welcome to go back through your notes and go through everything else and be ready for your quiz next week. All right. You have a wonderful day. See you soon. Bye.